In today's world of chemicals and other hazardous materials, it's critical to understand basic technical terminology in order to understand the potential hazard associated with such materials. When you're armed with information, the hazardous materials can be used and handled more safely. This short program addresses the terminology used with flammable liquids. You see different signs and warning labels on these liquids, but what do they really mean? What's a flash point, autoignition temperature, LFL, UFL, propagation of flame, and so on? The more you know, the safer you'll be in your work environment and even at home. First, let's discuss some basics. The first thing we need to know is the definition of a flash point. Basically, flash point means the minimum temperature at which a liquid gives off vapor in sufficient concentration to form an ignitable mixture with air near the surface of the liquid. There are several different testing methods, but how the flash point is tested or arrived at is not of concern in this basic overview. Let's look at an example. Let's say gasoline has a flash point of minus 55 degrees Fahrenheit. Now this means if the gasoline is cooled below minus 55 degrees, the liquid won't give off vapor in sufficient concentration to form an ignitable mixture with air near the surface of the liquid. Heat it up to minus 55 degrees or higher, then you have reached its flash point and have the potential for ignition. The flash point is a very useful measurement, particularly when you're storing, handling, or using the liquid in different temperatures and situations. Does flash point mean the liquid will explode at this temperature? All the flash point tells you is that the potential for ignition is there at certain temperatures. If you have an ignition source and the right mixture with air, yes, it can be ignited. Now, don't try this at home or at work, but you can probably put out a cigarette in gasoline without igniting the gasoline at room temperature. There's a couple of reasons for this. The concentration of vapor at the surface of the liquid may have too much gasoline and not enough air. It's sort of like your automobile flooded with gas. Not enough air, too much gasoline. Without the proper mixture of air, it may not ignite. Another reason for not igniting the gasoline could be the LFL or UFL. Flammable liquids and gases have a minimum concentration of vapor or gas in air, below which propagation of flame does not occur on contact with an ignition source. Now, this is known as the lower flammable limit, or LFL. There's also a maximum proportion of vapor or gas in air, above which propagation of flame does not occur. This is obviously the upper flammable limit, or UFL. A gasoline vapor and air mixture with less than approximately 1% of gasoline vapor is too lean. If there's more than approximately 8% of gasoline vapor, the mixture will be too rich. And now, don't run out and start experimenting, because these values change with atmospheric pressure and temperature. Certainly, this information is quite technical, but if you understand the general idea, you'll be better equipped to work with the materials. And never be afraid to ask questions when it comes to flammable liquids. The flammable range is the difference between the lower and upper flammable limits, expressed in terms of percentage of vapor or gas in air by volume. Safety and fire engineers often refer to this as the explosive range. The air and vapor mixture between the LFL and UFL are flammable and can be ignited by an ignition source. Now, which would you consider most dangerous? A 55-gallon drum filled with gasoline, or a 55-gallon drum with only a fourth of the drum filled with gasoline? Well, the answer depends upon the definition of dangerous. Both should be treated with respect and properly handled according to instructions. However, the air and vapor mixture in the 1/4 filled drum would be more easily ignitable than the drum completely filled with gasoline. Both have the same flash point, but one has a better chance of being ignited due to the air and vapor mixture ratio. What does autoignition temperature mean? Well, actually, it's the minimum temperature at which a flammable gas or vapor and air mixture will ignite from its own heat source or a contacted heated surface without necessity of spark or flame. Read the warning labels on flammable liquids, even the ones you use at home. Store in a cool, dry place. Do not heat above 110 degrees. The manufacturer knows what the auto-ignition temperature is and is trying to tell you not to reach this particular temperature. Is that the same thing as spontaneous combustion or ignition? When a flammable liquid reaches its auto-ignition temperature, it will ignite. Some of the more common problems include vegetable and animal oil and fats, coal, charcoal, and some finely divided metals. Rags or waste saturated with linseed oil or paint often cause spontaneous ignition. The best method of preventing against spontaneous ignition is either total exclusion of air or good ventilation. Certain other materials, such as sawdust, hay, grain, and other plant products, may ignite spontaneously, especially if exposed to external heat. There are quite a number of products that can spontaneously ignite, so it's always a good idea to follow the instructions and recommendations of the chemical manufacturer. Now, we're not trying to make you fire protection engineers, but just this small amount of information is extremely important to remember. Take a look at the flammable liquids you use at work and at home. Have you ever conducted an inspection of the garage or cabinets in your home to see what fire and explosion potentials you may have? At work, all flammable liquids must be properly labeled, stored, handled, and disposed of, and used according to your company's policies and procedures, and of course the chemical manufacturer's directions. Take the time to know what flammable liquids you're working with and what the necessary precautions are. Remember flash points, auto-ignition temperatures, and the basic principles of air and vapor mixtures. When a flammable liquid is within the explosive range, you need to take extra precautions and follow the rules. Flammable liquids are used in hundreds of thousands of processes, and they're used safely every day. However, the potential for mishaps is always there. Someone forgets to do this or that, or some procedure is violated. The answer to flammable liquid safety is to follow company safety procedures and work rules, and of course, the information provided by the manufacturer. Each employee holds the key to safety when working with flammable liquids. Knowledge is the first step, but then putting that information to work for you makes the difference in safety. Thank you.